As long as you have two consecutive numbers in an arithmetic sequence, you can easily determine the common difference. Subtract the previous term from the term that follows. You have found the difference. The word common indicates that the difference you found will remain the same for all of the numbers in the sequence. Sometimes it's called the constant difference because the rate of change is unchanging or constant. Here is an example. Find the missing terms for this arithmetic sequence and state the constant difference. First, subtract 8 from 19. 19 minus 8 equals 11. So, the number 11 is the constant difference. 30 is the next number in the sequence because 19 plus 11 equals 30. You can check your thinking by adding 11 to 30 to get the next term. The answer is 41. Likewise, 41 plus 11 equals 52. The next number will be 52 plus 11, or 63. For each task that you have been doing in class, you have been asked to find a recursive function rule and an explicit function rule that corresponds to the changing pattern. These two types of equations can help you predict the next term in a sequence or a term that is many steps away from the one you have now. This exercise is focused on writing just the recursive function rule for both an arithmetic sequence and a geometric sequence. The recursive function rule is best used to predict the next term. The notation for the recursive equation for an arithmetic sequence and for a geometric sequence is very similar. Both types of recursive equations begin with a known term or value of f of n. Mathematicians prefer to use the value of f of 1 if it is known. If not, as in this exercise, it is acceptable to use one that you do know. The second piece in both types of recursive equations is written f of n equals f of n minus 1, then write what you are doing to the previous term. In this example, two consecutive terms in an arithmetic sequence are given. You need to find the recursive function. Knowing the function is arithmetic tells you that you will be adding or subtracting a number. This is the constant difference, and you need to find it. Since f of 8 and f of 9 are consecutive terms, you can subtract 13 from 10. The constant difference is -3. Note that as n gets bigger, f of n is getting smaller. The constant difference is negative. Now write the recursive function. F of 8 equals 13, and f of n equals f of n minus 1 minus 3. To find f of 10, you would subtract 3 from f of 9. Since f of 9 equals 10, f of 10 equals 10 minus 3, or 7. Here is another example where two consecutive terms in a geometric sequence are given. You need to find the recursive function. Knowing the function is geometric tells you that you will be multiplying or dividing by a number. This is the common ratio, and you need to find it. Since f of 10 and f of 11 are consecutive terms, you can divide 45 by 9. The common ratio is 45 over 9, or 5. Now write the recursive function. F of 10 equals 9, and f of n equals f of n minus 1 times 5. What if f of 10 equals 45 and f of 11 equals 9? You always divide the term you have now by the previous term to find the common ratio. This would give us 9 divided by 45, or 1/5. The common ratio is a fraction, or you could say you are dividing by 5 at each step. The recursive rule would be f of 10 equals 45, and f of n equals f of n minus 1 divided by 5. Or you could write f of n equals f of n minus 1 times 1/5. You have been working on using function notation throughout this module. It should be becoming more natural for you to use it. Recall that the notation f of n refers to the output value when the input value is n. When the instructions tell you to find the indicated value of f of n, evaluate the respective function rule, substituting in the number that is given for the value of n. In this first example, given that f of n equals 6 to the nth power, find f of 2 and f of 0. The notation f of 2 means that you should replace the n in the rule 6 to the n with 2, then calculate the value of 6 to the second power. 6 squared equals 6 times 6, which equals 36. Therefore, f of 2 equals 36. The notation f of 0 means for you to find the value of 6 to the 0 power. This is a special case. Any number raised to the 0 power equals 1. 9 to the 0th power equals 1, 42 to the 0th power equals 1, 5/7 to the 0 power equals 1, 2.758 to the 0 power equals 1, and of course, 6 to the 0th power equals 1. Here is another example. What is the difference between f of n equals the quantity negative 5 to the n and f of n equals negative 5 to the n, given the instruction to find f of 3? When the negative sign is inside the parentheses, it is being raised to the same power as the 5. The notation f of n equals negative 5 to the third means to multiply negative 5 times itself 3 times. Negative 5 times negative 5 times negative 5 equals negative 125. The repeated 5s multiply to be 125. But you must consider the negatives. The expression negative 5 times negative 5 times negative 5 is the same as negative 1 times negative 1 times negative 1 times 5 times 5 times 5. Negative 1 times a negative 1 is positive, but we must multiply that answer times negative 1 again, making the final answer be negative 1. After this multiplication, you get negative 1 times 125, or negative 125. When the expression is f of n equals negative 5 to the third without the parentheses, the exponent n applies only to the 5. In expanded form, f of n equals negative 5 to the third, which equals negative 1 times 5 times 5 times 5, which equals negative 125. In this example, the parentheses did not change the answer, but you may want to think about when the two functions would get different answers. Here is one last example. Given that f of n equals 11 plus 7 times n minus 1, find f of negative 3 and f of 6. The notation f of negative 3 means that you should replace the n in the rule 11 plus 7 times n minus 1 with negative 3. Then calculate f of negative 3, or 11 plus 7 times negative 3 minus 1 equals 11 plus 7 times negative 4 equals 11 plus negative 28, which equals negative 17. In the same manner, replace the n in the rule with 6, then calculate the value of f of 6, or 11 plus 7 times 6 minus 1 equals 11 plus 7 times 5 equals 11 plus 35 equals 46.